Hey folks, I wanted to talk you through a technique when writing Python software to automatically manage opening and closing resources when they become necessary to have in your program, but ensuring that they are no longer accessible when they're not needed. And this is something that you've almost certainly seen before in files. The way that files work in Python is you open up a file, provide some operations on it, and then close it later. And the one real benefit of this kind of delayed model where you have something opening and closing means that your computer can actually do some optimizations. If you've opened up a file, done some operations on it, but don't actually mark that it's closed yet, your computer can assume, hey, whatever that you were doing with that file isn't done yet. So I can delay actually following up with a write command until that you either write enough data to make it worthwhile to spend time writing that data, or you close the file signaling that no other data is coming. So to give you an example of what that actually looks like to help win this home, let's run a little bit of example code that worked just a few moments ago. So here I've opened up a file named context.txt, and you can see right now it is empty. If I write to it, even though it says it wrote, that file is still empty. And it's not until I call the close operation that it actually gets written. And that's due to some optimizations with how your computer manages writing files to disk. Now you can see a problem here emerge right away, that if I don't remember to close a file, and then I assume that that content had gotten written later or in a different piece of software, then problems are going to arise. Data that I expected to be there won't be present. So the way that Python manages kind of making it easy for you to keep track of these resources like files and ensure that they get closed properly is this with syntax that you might have used before, and you can see that you can write some of your operations inside of that block, and by the time you finish it, that block would have all of that code inside of there gets executed. When the block closes, everything is over and the file will write to disk. Now this is a pattern that is used for things besides files, and you can use it for your own software using a library called contextlib. And contextlib makes it easy for you to write code that can be used inside of one of these with statements. And there are two core ways of going about it. And I ended up using both of them while writing some software over the weekend, or not over the weekend, over the late last week. I don't work over the weekend. That use both of these styles. So I'm going to walk you through them, show how they work in practice to hopefully cement the different ways you can use this tool. So the one way of doing it is to write into your class a enter and exit function. That enter function happens when I start the with statement, and the exit happens at the end of it. So we can see an example here of where I've used that in practice, that when I enter the block, I launch a thread that sits in the background and will write data to disk. Any new records will get written, and when that closes, I shut that thread down. So in this way, I ensure that I don't have a thread running when I don't expect it to be. Now, these enter and exit functions are what define those different types of operations. And Python knows to work with them if you take this object and have it subclass abstract context manager. So here you can see when I'm defining my database class, one of the tools that it's based on is a context manager, which means that when I use this object later, I can use it with the with syntax. And one example of that is actually in a function that uses the other kind, or the other way for creating a database, or creating a with statement. So here I'll just start off by showing you it being used in practice. So here I've created my database object. Now I want to work with it. So I call the with store function to open up all of that backing required by this database object to work correctly. And then when this function ends, it will close that up and I can rest easy knowing that any of the data that was written to that database has been properly backed up, and the thread that's sitting in the background doing the actual asynchronous writing has closed. This is actually running inside of another function that itself illustrates the other way of creating one of these contexts. Here from the contextlib, instead of creating a whole class based around it that defines a exit and enter function, all I do is I mark the function that I want to act as a context manager as a context manager with this particular flag. Now what this will do is it will turn your function into a context, and it will return any of the objects from it via a yield statement instead of a return statement, because what's going to happen is once this function is done running, it's going to finish running any other code in here. So let's see what happens. I'll show you an example of where that was used. So here I'm calling my new context function, and you can see it returns these 3 different objects. When this block here closes, when I go back to the regular indent here, it's going to go back, and the last thing that it will do is go back to the function that opened up the context, the .assemble, which is where I am now, and it will run the remainder of the function. Nothing happens besides exit this context and have any sort of closing operations needed for that one get finished. And this, I can actually show you what it looks like because I've got a lot of logging statements in the XML code I'm working with. And let's go take a look. So here, I've got a command that says at about 8 minutes ago, this particular run finished. Oh, actually, sorry, yeah, finished here. This function completed, and it's sending a shutdown signal. That means it finished the function. It's starting to close these contexts. One thing it does when it is closing those contexts is it's going back and calling this exit function, which, here's the exit function, and you can see it's triggering the last write to database. And if we go back here, look, there's that logging function. So this is hopefully reinforcing what I've been saying, is that when this, each time a context closes, it does one of 2 things. If you define that context using the context manager object, like I did with this database store, it calls exit. If I defined it using the function, it goes back and calls whatever is after your yield statement, and we'll run that until it finishes. So that's context managers in 8 minutes. I'll post all the links to the code that I'm showing here, as well as a link to the documentation for contextlib, so you can go and be able to read Python's full documentation, now hopefully with a picture for seeing how this can fit into your application. Have a good day.